In this video, we will learn about the Walrasian equilibrium and Marshallian equilibrium using the supply and demand functions. The question is, suppose that demand and supply functions in a market are given as quantity demanded is equal to 100 minus P and quantity supplied is equal to 200 minus 5P. We have to analyze whether the equilibrium is Walrasian stable or Marshallian stable. Okay, so let me draw a simple graph here. Okay, so we have quantity on the horizontal axis, price on the vertical axis. Okay, we are being given the demand function, that is quantity demanded is equal to 100 minus P and quantity supplied is equal to 200 minus 5P. Okay, we have unusual supply function here, you can see, and I will explain here. Let me first draw the graph of the demand function. Okay, so if I draw the graph of Q is equal to 100 minus P, so how do we draw the graph? Let us suppose when P is equal to 0, in this case implies Q will be equal to 100. Okay, so let us suppose this is here 100. Okay, P is equal to 0, and when Q is equal to 0 in this equation, P will be equal to 100. Okay, so price is equal to 100. Let me show it here, or let me draw. So we have this demand function. So usual demand function we have. Now what about supply function? Let me draw the supply function also. When Q is equal to 0, when Q is equal to 0 in this equation, that means 200 minus 5P is equal to 0, or 5P is equal to 200, or P is equal to 200 upon 5. So P will be equal to 5 ones are 5 fours are, so we get P is equal to 40 here. And let me draw it here. So P is equal to 40. Let us suppose it is here, it is 40. And similarly, when we plug P is equal to 0, Q will be equal to 200. Okay, so when P is equal to 0, Q will be equal to 200. I will not be showing this because I have to explain other stuff here. So we will have this kind of supply function. Okay, here this intercept is 200. Now what is the equilibrium here? Then we will explain the Marshallian and Walrasian. So stability. So we know that at equilibrium, what happens at equilibrium? At equilibrium, demand is equal to supply. So this is our demand function. That means 100 minus P is equal to, what is supply? Supply is 200 minus 5P, 200 minus 5P. Let us solve it for P. Transpose this term here and this term there, so we will get minus P. Transpose it here, it becomes plus 5P is equal to, we have 200. When I transpose it, it gets subtracted, so we get 4P is equal to 100. Dividing both sides by 4 implies P will be equal to 4. So 100 upon 4 is 25. So initially we get, okay, so P is equal to 25. So let me write it here. So at equilibrium we get 25. And what about quantity? Plug P is equal to 25 in either demand or supply function. So let us put it into the demand function. So Q will be equal to 100 minus 25. So quantity demanded will be equal to 75. So let us suppose this point is 75. Okay, so it is here Q, here we have this P initially. So we got equilibrium, price and quantity. Now we need to discuss about the stability of this very equilibrium. Okay, using the Walrasian approach and Marshallian approach. Okay, so let us first take the Walrasian case. Now Walrasian approach, talks about price adjustment. Okay, price adjustment, and I will be explaining it here. So let me first explain what is meant by equilibrium. Now, by equilibrium we mean equilibrium refers to a position of rest or balance. Okay, so at this point we have a rest or balance. So we get in demand and supply we mean where supply and demand functions intersect, that very point is called the equilibrium point. Okay, so simply it refers to a position of rest or balance. So demand and supplies are balanced at this point, so this is equilibrium. Now what about stable equilibrium and unstable equilibrium? Okay, let me explain it with an example. Let us suppose I have this bowl, and in this bowl, let us suppose I have this ball at this bottom. So I am saying that this ball is at equilibrium, it is at rest, at balance. Okay, so this is equilibrium. Now suppose if there is some disturbance to this ball, okay, if I move this ball once, so it will reach first here, okay, then it will go here, and then there will be adjustments, it will go here, then here, and finally it will reach to its original position. So in this case we say the equilibrium is stable, because when there was external force or when there were some forces that tried to deviate or disturb this equilibrium, there were the market forces that helped it to reach to its original position. So we say it is equilibrium stable. Okay, stable equilibrium. So this is stable equilibrium. Now what about unstable equilibrium? So let me draw this bowl again, but upside down. If I have a ball on this here at the top, now if this ball is disturbed once, so it will either go downwards here or it will go downwards here, but it will not be able to reach to its original position. Okay, so we say this equilibrium is unstable. Initially it is an equilibrium because it is at rest, it is at balance, but when this balance or rest is disturbed, we are not able to get it back to the original position, so we say it is unstable equilibrium. Okay, that means once equilibrium is disturbed, market forces tend to move it further away from that very equilibrium, so we will not be able to reach to the initial point. Okay, now there are two approaches of seeing the stability and instability. That is, first is Walrasian approach. Okay, so Walrasian approach works in the price adjustments. Okay, let us suppose price changes. Okay, in this case let me show it here. Let us suppose by some reason initially we were at Q. Let us suppose price increases by some reason to P1. Okay, P1. Now at P1, so let me write it here. If price increases to P1, what happens here? You can see this is our supply function, this is our demand function. So here demand is more, supply is less. Okay, what happens at this point at P1? Demand is more. Okay, so demand is greater than supply. Okay, in this case demand is greater than supply. Now what happens then? We have the excess demand. If we have the excess demand, what will happen? Firms will charge higher price. Firms will charge higher price. let us say P2. Okay, let us suppose we have this P2. So what happens, initially we were at this point, so when the equilibrium was disturbed, we reached here. Okay, but when reaching at this point or this point, there are forces in the market that moves this price in this direction. Okay, so we are not able to reach back to the initial point. Why? Simply at P1 what happens, we have demand is more than supply. When demand is more than supply, firms will charge higher price. That means we are moving to upward direction. We are not going back to the initial direction. Okay, so when firms charge higher price, price will increase. Okay, that means this equilibrium is unstable. Okay, so it is unstable. And same is the case when if price is at this point. Okay, let us suppose price decreases by some reason to P2. Okay, so let us suppose we are at this point, P2. What happens at P2? Here you can see, here supply is greater than demand. Okay, so here you can see red denotes the supply, this is demand. So at P2 we have supply is greater than demand. Okay, so what will happen here? Since supply is greater than demand, firms will charge less price. Okay, they will decrease the price. So price will decrease. If price decreases, we are moving to this direction. So let us suppose P3. So we are going further away from this initial equilibrium. So we say it is unstable in case of Walrasian. But what about Marshallian approach? So we see that Walrasian approach works through price adjustments when price is disturbed at P1. So we are moving away from the initial equilibrium to P2, P3 and so on. So we are not going to initial position of P, which would have given us the stable equilibrium. Now let us see the Marshallian. Okay, so let me be very specific here and let me draw another graph. Again this graph, so we have quantity here, price here. Okay, so we have, this is our demand function. Okay, and let me draw the supply function. Okay, this is our supply function. Initially we were at this point Q. Okay, now let us take the Marshallian approach. So Marshallian approach works through quantity adjustment. Okay, so again take this example. So let us suppose by some reason we were at this point, let us at Q. Okay, let us suppose quantity increases to Q1. Okay, Q1. So let us suppose Q1 quantity decreases to Q1. Okay, at Q1 what happens? We have what we call supply price is greater than demand price. Okay, so let me write it here. So supply price is greater than demand price, or we can say we have excess supply price. Okay, when we have the excess supply price, consumers are not willing to pay more price than being charged by the suppliers. This will induce suppliers or producers to decrease the price. Okay, since supply price is greater than demand price, here you can see consumers are not willing to pay more price than being charged. Okay, since price are being charged at this point, but demand is only consumers are seeing it at this price. Okay, so there is no willingness to pay higher price by the consumers. This will induce producers to decrease price. Okay, implies price will, or rather this will induce producers to decrease supply. That means they will decrease the quantity. So if they decrease the quantity, initially we were at this point, so we will be going in this direction, because here quantity is more when willingness to pay by the consumers is less than the price they are being charged. So suppliers will decrease the quantity. When they decrease the quantity, let us suppose we are at this Q2. Okay, so we are reaching at this point, we are reaching to the direction of the equilibrium, and this adjustment will continue till we reach Q, which was our initial equilibrium. Okay, so let me explain it again, because I was not able to draw the graph smoothly. Okay, so let us suppose this is our demand function, this is our supply function. Okay, initially we were at this point Q. Okay, let us suppose quantity decreases due to some reasons to Q1. At Q1, what is demand price, sorry, supply price is more than demand price. Okay, we have excess supply price here. That means consumers are not willing to pay more price than being charged by the producers. This will induce producers to decrease the supply, so supply will decrease, let us say to Q2. Okay, since we were at this point, we moved to Q1 by some reason, then we moved back to Q2, and this adjustment will continue till we reach back to the initial point. So we can say that in this example, numerical example, it is Marshallian stable. Marshallian stable. Okay, actually I have made the stability condition in case of Walrasian and Marshallian in detail. You can check out that very video also, but it was only to explain this numerical here. I hope I make myself clear. Thank you.